My dear students of geology, today we will discuss one of the important topics of structural geology, that is attitude of bed. We will discuss this topic in the following points. First we will describe its definition, then we will describe how these deep and strike data are being represented in azimuthal form or in quadrant form, and what are the symbols that are used to describe these features in maps. Then we will derive the mathematical relation that exists between true deep and apparent deep in that direction, and another mathematical relation that is existing between two apparent deeps. And after that, we will discuss some of the problems, common strike and deep problems by mathematical relation or by geometrical construction or by the stereo diagrams. Let us start. First, we will discuss about the definition. All planar bodies which are bedding planes or sistercity planes, correlation planes, joint planes, fault planes, etc. All these planes are described with respect to two terms, that is their deep and strike. These two terms together describe the attitude of bed. So what is deep? The deep of a planar body is defined as its angle of inclination measured with respect to the horizontal plane. So deep of any inclined bed is simply it is the angle of inclination that it makes with respect to one horizontal plane. And what is the strike? Strike, it is the trend of the line produced by intersection of the horizontal plane with that of the bedding plane, whose strike is to be determined. So strike is a feature that comes into picture when two planes are considered. There is the inclined bed and another is the horizontal plane. Their intersection line is the strike. So strike is described with respect to its direction at both ends. And we do not have any strike in case of a horizontal bed, because horizontal bed touches the inclined bed or the horizontal bed touches the horizontal plane at all points. So we cannot get a line. That's why we describe the strike of the beds which are inclined or which are vertical. Now, the deep of a plane is always measured in a vertical plane perpendicular to strike. That we have to remember. Deep is the angle of inclination, no doubt. And deep is always measured in a vertical plane perpendicular to strike. And this deep value is described as the true deep. And this deep is the maximum amount of inclination for the concerned inclined bed. So true deep is always the highest value for a dipping bed. When deep is not measured in a perpendicular plane to strike in a vertical plane, it provides a deep value which is less than the true deep value. So this deep is described as apparent deep. So true deep value for a bed is always the maximum value, and apparent deeps, they all have a value less than the true deep. And the deep along the strike of the inclined bed is 0. And deep is expressed in terms of its angle of inclination, that is either from, it will start from 0 and it may go up to 90. And it is described with respect to this angle and with respect to its direction of dip. Strike is expressed by its direction at both ends of the line. Let us see this diagram. This is a three-dimensional diagram, and here is the bed. This is the bed. This is the bed, and this amount theta is the angle of dip. So ABCD is the horizontal plane. ABEF is the dipping plane. AD is perpendicular to the AB line, that is strike. POQ is the dip amount, that is theta. ROS, it is apparent dip, that is alpha. So we can consider that when dip is measured in a direction perpendicular to strike, this is true dip. And when this is measured not in a perpendicular direction but in a vertical plane, this is apparent dip. And this apparent dip value will always be less than that of the true dip. So we discussed about the definition of the dip and strike. It is related to the attitude of the beds. Now we will discuss how which data are being represented in azimuthal form or in quadrant form. So we will show how the strike lines are being represented and how the dip amount is being represented. The azimuthal form is a whole circle representation of strike in 3-digit form and its dip value in 2-digit form. We know dip value varies from 0 to 90 degree, and the strike direction, it will start from 0 to 360 degree. So it is represented in 3-digit form. Strike is represented in 3-digit form. Dip represented in 2-digit form. And when you describe the attitude of any bed or any planar body, we show the attitude data with strike amount first, followed by dip amount. And in this process, we follow the right hand rule. This convention is that first strike is written, followed by dip, following the right hand rule. That is, the dip direction is always perpendicular to strike value to its right side. Let us say this is the strike, and we have the strike value mentioned 0, 4, 5. So the other end will be 2, 2, 5. This amount, this will be the value, because this amount is 180 degree. So simply writing a 3-digit value will be enough to represent the strike. Then we will see that the dip amount is being mentioned. So dip amount will be towards the right of the mentioned strike value, and it will be perpendicular to the strike value. So this will be the strike direction. Now this will be the dip direction. This is strike according to right hand rule. This will be the dip direction, because this is the strike value mentioned. So towards its right we will have this direction. If we will have mentioned strike value 2 to 5, then dip direction would have been to this side, because this is the right side of 2 to 5. So strike line remaining same, we see the dip direction can be in 2 directions. That's why we have to follow the right hand rule when we represent the data in azimuthal form or in whole circle reading form through digits only. So if this has been mentioned, so strike will be like this. It will be 45 degree from north, so 0, 45 degree. Then dip direction will be towards this side, because right of 0, 45 will be this direction. This will be 90 degree. So it will be 135 degree direction along which the bed is dipping. And if this 60 degree will be the dip amount. Here we do not write this. We mentioned the dip value here. So here we will have to write 60 degree, and this is 0, 4, 5 degree. 0, 4, 5 degree is the strike direction, represented in 3-digit form. 60 degree the deep amount, it is represented in 2-digit form, and deep direction is towards the right of the strike value. So this is to this side. If we would have mentioned the strike value instead of 0.45, we had mentioned the strike value 135, then the deep direction would have been to this side, and this would have been the right side of 135. So strike remaining same, the deep can be in two the opposite directions, perpendicular strike. Hence, the right hand rule is to be followed when attitude data is represented in azimuthal form or through use of digits only. Now, we will switch over to quadrant form. How the attitude data is being represented in quadrant form. So we have the circle. This is north, this is south, this is east, this is west. So we have the 4 quadrants. So entire this will be used to describe the strike in quadrant form. Let us say the attitude data is north 30 degree east, south 60 degree southeast. So we have to first write down the strike, that is north 30 east. So this will be 30 degree from north towards east. So north 30 east. The other side will be south 30 west. Simply mentioning north 30 east will automatically give the value on the other edge, that will be south 30 west. So this is the quadrant form. Here strike is written in quadrant form with respect to north and south. With respect to, remember, with respect to, it will mention with respect to north and south direction, and the deep amount with respect to its direction. So this is the whole circle. See? This is north east means north 45 degrees, south 45 degrees west. North west means north 45 degrees west, south 45 degrees east. And so the strike is described with respect to north and south. This will be north east. The other end will be south west. So what do you mean by north east? What do you mean by north east and south west? If this is the circle, this is north, this is south, this is east, this is west. Exactly this will be northeast 45 degree. This line, this is northeast because it is north of northeast. Northeast means north of northeast. This is northeast line. So towards north of this line we have northeast. It will have 22.5 degree from north. So the other end will be south west. Similarly, this line will be north west. This is northwest. North of northwest. This will be north direction of northwest. So north of northwest. It will be north 22.5 degree west, south 22.5 degree east. So in this form we represent the attitude data. So we learned how we represent the data in azimuthal form or in quadrant form. So in azimuthal form we simply use the digits. First we mention the deep amount in 3-digit form, then we mention the deep amount following the right hand rule. And in quadrant form we represent the strike data in form of quadrants. In 90 degree to the strike we have the deep direction, we have to mention the dip direction, because we do not have to follow the right hand rule in this case. We follow the right hand rule when we represent the data in azimuthal form. But when we mention the quadrant form, there we have to mention the strike, then the dip direction with dip amount. This is dip direction, this will be dip amount. So first we have to mention the strike in quadrant form, then the dip amount, then the dip direction. Simply mentioning southeast will be enough, because we know the strike, we know not, this is not 30 east strike, so perpendicular to it will be dip direction and it is towards southeast. So this is the southeast direction. So we simply add 90 to this direction and we get the dip direction. So mentioning southeast is enough to find out the dip direction, because we have to add 90 to this north 30 east toward this side, so that we will get the dip direction. North 30 east means it is south 30 west. But if we do not mention this southeast, then we will be in problem, because we can have dip direction to this side or to this side. The amount remaining same, we can have dip to this side or dip to this side. So we have to mention the strike direction, then the dip amount, then the dip direction in quadrant form, in order to have a clear picture of the dip and strike value. Suppose a bird is dipping 30 degree, along south 45 degree west. So this will be, this is south, this is north, this is south 45 degree, this is south 45 degree east, and north 45 degree west, and bird is dipping south 45 degree west. So bird, so this is the strike, bird is dipping towards west of this line. So this will be the west of this line. So we have to add 90 degree. So south 45 degree east means it is 135 plus 90, it will be 225. So this will be 225 direction, or it will be 45 degree from south towards west. It will be south 45 degree west. Now I think it is clear to all of you how we represent the dip and strike data in azimuthal form or in quadrant form. Now let us see how the symbols are being used to describe the altitude data. At a bedding plane. Bedding plane, we first draw the strike in a long line, and perpendicular to it a small line which will indicate dip direction, and to represent the strike value we have to mention this. This is the line to represent the strike with the strike value here. This will be 315 degree, let us say. So dip direction will be to this side or to the other side. Here we have mentioned this is north 45 degree west, south 45 degree east. So this is north 45 degree west, south 45 degree east. This is strike. Then 30 degree southwest. So southwest, this side. So dip direction will be to this side. Here we mention the dip amount. A small line perpendicular to strike will indicate the dip direction, and the dip amount is written at the one end of this small line. So this is for inclined bed. If the bed is vertical, simply a line indicating the strike, then a small line like this, so that will be indicating of the vertical bed. So here it is 0.45 degree is indicating of strike, and when it is vertical it has no dip direction. So simply a cross line like this will indicate a vertical bed striking north 45 degree east. And if it is horizontal, we simply draw a circle with a plus sign within it. So this is a horizontal bed. And if it is a foliation plane, then we draw a long line to indicate the strike, a triangle like this with deep amount at its one end, like this. This is for a foliation plane dipping 60 degree towards northeast, having strike 315 degree. And if it is a vertical plane, then we draw these triangles on both sides of the strike line to indicate a vertical foliation. So this will be strike direction, and this is the deep, indicating of deep value of the foliation. Deep value of the foliation. Deep value of foliation. So we have to draw the first one line, then the triangle at both ends to indicate vertical foliation. If it is horizontal foliation, then this is like this. This is horizontal foliation. Then if it is cleavage, we draw a line indicating strike, and this is the cleavage, indicating of cleavage, and the deep amount is mentioned here. Let us say 30 degree or 40 degree or 60 degree, like this. So this is a inclined cleavage. If it is a vertical cleavage, then this is the vertical cleavage. Here we mention 90 degree. If it is a horizontal cleavage, then we draw this is a horizontal cleavage. So, and if it is joint, then we if it is joint, then we draw a line to indicate the strike, then a figure like this. A rectangular block which will indicate the deep direction. Here you have to mention the deep amount. Deep amount we have to mention. If it is vertical joint, then this will be like this, both sides, on both sides of the strike line. If it is horizontal, then we have to draw like this. So this is horizontal joint. So we could know how the symbols are being used to represent the bedding planes, joint planes, foliation planes, cleavages on the map. Now we will switch over to the representation of linear features in map, or how linear features are represented in map. We know the lineations or linear features are represented with respect to their plunging direction and plunge amount. So it is represented in terms of its plunge angle, which is same to that of the dip in case of a planar body. At the value of plunging direction. Plunge of a linear feature, say fold axis, hinge line, lineations, etc., is defined as its angle with respect to horizon measured in a vertical plane containing the lineation. The convention of the dependence on the lineation is that first plunge amount is written in 2-digit form, followed by plunging direction in 3-digit form when it is being represented in azimuthal form. In case of planar body, for representing deep strike, we are using fast strike, then deep value. But in case of linear body, first we have to write down the plunge amount in 2-digit form, followed by the plunging direction in 3-digit form. So, if we say 0-45 degree, this is not 45 degree east, that is the plunging direction, and deep amount or the plunge amount is 20 degree, like this. So, first we write down the plunge, then the plunging direction in azimuthal form. But when we go for quadrant representation, we have to mention the deep direction. We have to mention the deep direction as here, and the deep amount. So, direction, and this is the plunge amount. Deep of a plane, plunge of a line. So, the quadrant form, it will be 20 degree along north, 45 degree east for this. Now, how these linear features are being represented in maps? Simply a line with an arrow with plunge amount at its arrow end will indicate the plunging direction with the plunge amount. Let us say linear body having 30 degree plunge along north 45 degrees. So, this is north 45 degree east, this is north 45 degree east, and the line is like this, and the plunge amount has been mentioned here. If it is vertical, then this line will perpendicular to it, this is a vertical lineation. If it is horizontal, then goes on all sides. We have to show it in this form. This is horizontal lineation. And we may have a dipping body with lineation, or a dipping bed containing the lineation. So, let us say this is dipping bed having north 45 degree east, south 45 degree west type, dipping 60 degree towards south east. If it is containing a lineation, we can show the lineation like this. That means this plane striking north 45 degrees, 60 degrees southeast dip is containing a lineation which may have plunge direction toward this side with plunge amount, let us say 40. Because if this is the deep value, plunge value will be either equal to that or less than that. So, this is 40. It cannot be more than that. In a plane, it cannot be more, because the plane is containing this lineation. So, this amount will be less than, the plunge amount will be less than the deep amount, or it may be equal to deep. If the plunging direction of the lineation will be along the deep direction, then it will be 60. Otherwise, it will be less than the deep value. So, we can show the lineations with the arrow line in the planar bodies to indicate its plunging direction and plunge amount. And in case of the beds where the bed is inverted, we use a symbol like this, inverted bed with strike, and this is dip direction, like this. So all these are the ways to represent the dip and strike value or the plunge value of the linear features in the maps. So we discussed till now what is dip and strike, what is plunge, how they are being represented, whether they are represented in azimuthal form or in quadrant form. If they are represented in azimuthal form, digits are only used. For planar body, the right hand rule is being followed. And in case of linear bodies, first we write down the plunge amount followed by the plunging direction in 3 digit form, and how these planar bodies and linear bodies are represented in maps. Next, we will switch over to the mathematical direction that can be used to establish the relation between true dip and apparent dip. We can mathematically deduce the relation. Let us say this is the inclined bed. This is the inclined bed and this is the horizontal plane. This angle is the dip. This angle is the dip. This angle is the dip, because this is the plane. This is the horizontal plane. So ABC is the horizontal plane, ABEF is the dipping plane, dip amount theta, that is x or y, apparent dip alpha, this is alpha, because apparent dip when the dip is not measured perpendicular to strike. So this is the strike. It is not perpendicular to strike, and this angle will be alpha, which will be less than theta. So AB strike line, apparent dip alpha, x dash O y dash. So now we will deduce the relation between the true dip, apparent dip, and the angle between the true dip direction and apparent dip direction. So this is the true dip direction, this is the apparent dip direction, this is true dip direction. So let us see these two triangles. Triangle OXY, which is the triangle for the true dip direction, and triangle OX dash Y dash is the triangle for apparent dip direction. So in OXY, tan theta will be XY by OX, XY by OX. So XY is the vertical spacing. XY is the vertical spacing, and this is OX is the horizontal spacing. So this amount is the dip. So tan theta will be XY by OX. Similarly, in triangle OX dash Y dash, tan alpha will be X dash Y dash by OX dash. But what about X dash Y dash and XY? They represent same depth from the horizontal plane to the dipping bed. This is the horizontal plane, and this is the base of the dipping plane, and we have this is the horizontal component, this is the vertical component. So vertical components are of same depth, same length. That's why when we divide these two, we cancel them. XY and X dash Y dash, they are cancelled. We have tan theta by tan alpha is OX dash by OX. OX dash by OX. Now we will consider this triangle. We will consider this triangle, which is on the horizontal plane. So this angle is 90 degree, because this is horizontal plane, and this is perpendicular to that, perpendicular to strike, and it is this vertical triangle. So this line is the strike. This line is the strike line, parallel to this is the strike line. So this angle will be 90 degree. This angle will be this angle, this angle is 90 degree, or this angle is 90 degree. So the triangle OX dash, it is a right angle triangle, as the true dip is measured in a vertical plane perpendicular to strike. So X dash XO or OX X dash is 90 degree, and the angle between true dip direction OX and apparent dip direction OX dash is delta. Let us say delta. So OX dash X, it will be 90 degree minus delta. Now from the rules of geometry of triangles, we have OX by sine of OX dash S will be OX dash by sine OX X dash. This side by sine of this angle is equal to this side by sine of this angle. This is the formula. So OX dash by OX will be sine 90 by sine 90 minus delta, or it will be 1 by cos delta. Now comparing this equation with this equation, we get tan theta by tan alpha is 1 by cos delta, or tan alpha is tan theta into cos delta, or tan of apparent dip, this is the formula, tan of apparent dip is tan of true dip into cos of the angle between true dip direction and apparent dip direction. So this is the formula that exists between true dip and apparent dip and the angle between their directions. So this is the case when we talk about the data that is represented in terms of true dip, apparent dip and their direction. But if two apparent dips will be provided, then our mathematical reduction will be something different, that we can deduce by using this type of diagram. Here, this is the diagram, mathematical relation between two apparent dips, and it is in the same similar way we have deduced. We have taken, this is the one of the apparent dip direction, this is another apparent dip direction, this is the true dip direction, and we have tried to solve it in the similar manner as we have discussed the previous mathematical relation, and finally we have got, this is the formula that relates the two apparent dips and the angle between the two apparent dips, and I will now describe how we can deduce this mathematical relation. Our deduction is in the same manner as we have discussed the previous one. So ABCD is the horizontal plane, ABEF is the dipping plane, ABEF is the dipping plane, alpha theta is the true dip, alpha and alpha 2 are two apparent dips. We will establish the relation between two apparent dips, alpha and alpha 2, and the angle between their directions, delta. Let AOX double dash, AOX double dash, this angle, this angle, this angle, B delta. So angle between the strike and one apparent direction. This is one apparent direction, this is alpha 2, and this is the strike. So in OX double dash Y double dash triangle, similarly tan alpha 2 will be this much. In the same manner, the other apparent dip will, in the OX dash Y dash triangle, tan alpha 1 will be x1 x dash y dash by OX dash. In dividing them, we get tan alpha 2 by tan alpha 1 by is equal to OX1 by OX dash by OX double dash. Tan of alpha 2 is tan of alpha 2 by tan of alpha 1 is equal to OX1 by OX double dash. Now compare the two triangles OX dash x double dash x and OX dash x, because we in the previous formula tan alpha 2 by tan alpha we have got the two terms x OX dash and OX double dash. We have to eliminate them in terms of the angles. So now we will consider these two triangles OX x double dash and OX x dash. These two triangles we have to compare. So in OX x double dash, cos of XO x double dash, because we want to eliminate this one. So cos of this angle, this by this, because this is 90 degree. So cos of this one, cos of this angle will be equal to 90 minus this delta. So cos of this angle is equal to OX by OX double dash. This one. Cos 90 minus delta or sin delta is OX by OX double dash. Now in this triangle, in the triangle containing alpha 1 at the apparent dip, we now find out the cos of this angle. We have already found out the cos of this angle. Now we will see the cos of this angle. This is this angle is the angle between the two apparent directions. Let us say that is sigma. The angle between two apparent directions is sigma. Then if we consider x double dash OX angle as gamma, then this angle will be equal to delta sigma minus gamma. That's why this is cos sigma minus gamma. So cos sigma minus gamma. Cos of this angle is equal to this by this, OX by OX dash. So OX by OX dash is the cos of angle, cos of this angle. If we take this angle, total this angle is sigma and this small angle is gamma, then this will be sigma minus gamma. This is sigma minus gamma. So now if you compare these two, equation 4 and equation 5, we get, by dividing them, cos of this angle by sin delta is equal to OX double dash by OX. Common will be OX, that will be cancelled out. So OX dash by OX double dash by OX dash, which is we have found out here, and now we got the value of OX double dash by OX is this value. So we compare them, compare these two, we get tan alpha 2 by tan alpha 1 is sin delta by cos sigma minus gamma. We solve them. If we get this angle, if you get this value of this delta, then we can know the strike line, then we can find out the, we can solve the problem using apparent dip and true dip direction. Apparent dip values, we can find out the true dip. So our purpose will be solved if we know this angle delta, and this delta has been found out by solving the above equations in comparing equation number 3 and equation number 6. We finally solve the value to find out the angle delta. We find out the angle delta as cot inverse of this one. This is the angle between the two apparent dip direction. This is apparent dip, this is apparent dip. So all values are known. We get this one. Then by using this, we will get the strike. Perpendicular strike will be the dip direction. So we have got two apparent dip directions, two apparent dip amounts, and the dip direction and the dip direction and apparent dip and the strike value. Now we can easily solve to find out the dip amount. So alpha 1, alpha 2, delta are known, delta value can be known, and hence strike can be found out, from which true dip direction and amount can be found out. So this is all about the mathematical relation that I wanted to discuss in order to show how mathematically we can solve the problems related to true dip and apparent dip. Next, we will switch over to the representation of the attitude data in the stereo nets. How stereo nets are being used? We have two types of net. One is Wolf net, the other is Schmidt net, or one is equal angle net, the other is equal area net. And to represent planes, we take use of the great circles, and to represent the strike, we take use of the small circles.